Welcome to my open learning session where I'm going to catch up with deep learning. I figured out after doing a few videos that I have to actually catch up math. So it makes no sense for me to learn more advanced topics or try to apply machine learning if I have no real grasp and understanding behind how the math works. So I will work out the math by myself. Sometimes I will watch a video, but in most cases I will do reading and exercises. I have to warn you, I'm a bit of a slow learner, and sometimes I have to state the obvious thing like 3 or 4 times. I will go back to topics um, and try to attack it from a different angle. So this series might only be interesting for you if you are struggling with math and you want to have a sparring partner, just watching me learning and learning by my side. Um, so I will use only public available sources so you can follow along. And the book I was recommended is this Mathematics for Machine Learning. You can find it online if you type MML-book in any search engine. It's also hosted on GitHub. I will do my notes in this PDF. I'm not sure if I'm allowed to upload it. Maybe I will figure it out later. And I also have a canvas on a different screen where I will just write my thoughts. And yeah, so let's start. This book is divided in two parts. Part one is the mathematical foundations, and the second part is, I think, it's more about applying the machine learning mm, under the topic central machine learning problem. So I'm not sure if I will do also part two. Let's just start with part one, which are like 250 pages of math. So this would take a while. Um, yeah, so let's go into it. Maybe we can skip the first introduction part, but let's take a look at it. I will mostly try to read out the document, but not all of it. Like if I'm just skimming it or it's not so relevant, I will skip it. So why we want to learn machine learning, I guess if you're watching this video, you don't need the why. Finding words for intuitions. Yeah, that's important. So it's the first time I'm recording here on my iPad. I'm not sure if it's easy to follow where I am. It might be nice if I had some kind of a laser pointer. What is this? Okay, I think this is the important part here. We represent data as vectors. We choose an appropriate model either using the probabilistic or optimization view. We learn from available data by using numerical optimization methods with the aim that the model performs well on data not used for training. So that's obvious, like you need to perform well on things you have not seen before. Otherwise, it's just memorization or compression if you want to. So there are two ways to read this book, bottom up and top down. Yeah, so in the past I tried more this approach where I'm just facing the problem and then trying to figure my way out somehow from top to down. This works in most cases, and this is actually the more realistic and more sane approach. So don't learn what you don't need. Like try to do something, and then you're like, okay, how do I do this? Then you are like figuring out. But for machine learning, like you need a strong you need a strong reason to uh, to do this. You need a strong why to actually justify building up the concepts from foundation. And if you don't have a strong reason, you will give up because it's so much work to do. And my goal is not just to be able to use AI models like through an API, but to actually understand and to um, create fine-tuned models for applications or use cases I see a good fit in. Something where I can provide or extend the model. So something like having the ability to add value. And I don't think that just applying these APIs to a software is enough. So that's my why, and I'm estimating I need around 1,000 hours to become an expert. So this will take me like, I don't know, a year or two. So if you want to join me, welcome. All right, so I think this is the most important part of this. Here they're also showing us what they actually are focusing on. So the whole machine learning part sits on 4 pillars. I can maybe increase the size here. So they have regression, then dimensionality reduction, this part, density estimation. I think what they mean with density estimation is something like generation, like having some kind of a probability distribution, and you want to sample. So you want to sample an image from the distribution which was learned. For example, you learned how to generate cat images, and I think math people talk different. They say something like, we want to sample a data point from the distribution X or whatever, and this distribution means a pool of possible cat images. This is my guess, but we will find out. And classification, even though I know that you can link those two, so you can do some classification using regression, but obviously this is shown as an own pillar, so it must, like, there must be different ways to do classification. And another big part which I saw online is what they call tensor what is it, operations, math, algebra. I'm not sure if this is part of linear algebra or this is like more a special case. But this, if this book is not providing well, it's not providing the math for it, then we might have pivot somewhere else. But I think this is enough for at least a few months. All right. Okay, so one problem I found with this book is that the exercises are not open. The solution to the exercise are not open. Maybe I'm wrong. Please correct me. Otherwise, I have to try to find other worksheets or so. Okay, so I think I will take a short break here, and then we will come back to basically chapter 2. We finished one chapter, huh? That was quite fast.